Welcome back to Arxflix. Today, we're diving into a fascinating paper titled Contrastive Preference Optimization, Pushing the Boundaries of LLM Performance in Machine Translation. This research tackles the challenge of improving machine translation, Montana, performance for moderate-sized large language models, LLMs. The authors argue that while these LLMs show promise, they often fall short compared to traditional encoder-decoder models or larger LLMs like GPT-4. The paper highlights the limitations of supervised fine-tuning, SFT, for LLMs in Montana. SFT aims to minimize the difference between model outputs and reference translations, but the authors argue that even human-generated references can be flawed. This figure shows an example where a human-written reference omits information, while model-generated translations are actually better. This raises the question, are references truly gold standard? To address these limitations, the authors propose contrastive preference optimization, CPO. CPO trains models to avoid generating translations that are good but not perfect, by learning to prioritize higher quality translations and reject those with minor flaws. The key to CPO is the use of preference data. This data consists of triplets: a reference translation, a translation generated by GPT-4, and a translation generated by ALMA, a strong LLM-based Montana model. Reference for evaluation models like QEXXL and XOMI are used to score these translations. The highest scoring translation is labeled as preferred, and the lowest scoring as dispreferred. CPO is designed to be more efficient than direct preference optimization, DPO, a similar approach used in RLHF. DPO requires storing both the model and a reference model, which is memory-intensive. CPO overcomes this by approximating the DPO loss using a uniform reference model. This approximation allows CPO to be more memory and speed efficient. The authors conducted extensive experiments on various translation directions, comparing CPO with SFT, DPO, and state-of-the-art models like GPT-4 and WMT competition winners. The results show that CPO significantly improves the performance of ALMA models, achieving results comparable to or even surpassing GPT-4 and WMT winners. Notably, CPO outperforms SFT on preferred data and DPO, demonstrating its effectiveness in pushing the boundaries of LLM performance in Montana. This paper makes several important contributions. It highlights the limitations of SFT and the potential for model-generated translations to surpass human-written references. It introduces CPO, a novel training method that leverages preference data to improve translation quality and efficiency. It demonstrates the effectiveness of CPO in achieving state-of-the-art performance in Montana for moderate-sized LLMs. This research has significant implications for the future of Montana, suggesting that preference learning can be a powerful tool for improving LLM performance in various NLP tasks. Thanks for watching. Don't forget to like, subscribe, and share this video with your fellow researchers. And be sure to check out the paper for more details and analysis. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.